You know how your computer works? With all the windows and icons? It just feels right, doesn't it? So intuitive. But here's the thing. That wasn't an accident. It wasn't inevitable. Nope. This is the story of how the way we use computers today actually started as this really radical dream way back in the 1960s.
So let's meet the Dynabook. I mean, look at this thing. This was a concept dreamed up by this genius computer scientist, Alan Kay. And get this was way before anyone had ever even heard of a laptop or an iPad. He imagined it as this personal, totally portable computer for kids of all ages. A dynamic medium for learning, for creating. Just wow.
And the idea here, it was absolutely revolutionary. This was not just about, shrinking a giant mainframe computer so it could fit on your desk. No. The goal was a complete paradigm shift, what he called a qualitative shift in belief structures. It was about creating this symbiotic relationship with technology, turning the computer into a medium for thought itself, basically an extension of your own mind.
Okay, so a vision that big doesn't just pop into someone's head out of nowhere, right? It was actually built on this incredible foundation of groundbreaking work. It was like a collision of all these amazing ideas from the true pioneers of the 1960s.
And it pretty much all starts right here, with Ivan Sutherland's Sketchpad. This was basically the invention of modern interactive computer graphics as we know them. For the very first time, a person could literally draw directly on a screen. You could manipulate shapes and lines not as just, a bunch of static pixels, but as real dynamic objects.
Now, the idea at the heart of Sketchpad was it was so deep. Here's how it worked. You could create a master drawing of something, let's say a bolt, okay? Then from that one master, you could create countless instance drawings. And here's the magic part. If you changed the master drawing, all the instances would change automatically, instantly. This was a completely new way to think about information.
So, for the young Alan Kay, seeing this, it was a genuine aha moment, a total epiphany. It planted this incredibly powerful seed in his mind, this idea of objects, of masters and instances. It was almost like a more biological way of organizing complex stuff. It completely rewired how he thought about what a computer could be.
Okay, so at the same time, over in Norway, of all places, there's this new programming language called Simula. And what it did was give this visual idea from Sketchpad a real formal structure. Simula basically took that concept of masters and instances and turned it into actual code. Now, they called them activities and processes, but the core idea, exactly the same. Independent things that could make copies of themselves.
And this is where Kay has his next big light bulb moment. He's thinking, okay, if you can structure data this way, why not the entire computer? Instead of one giant clunky program, what if a computer was more like a community? A community of thousands of tiny independent little computers, or objects, all just talking to each other.
So while all that's happening, you've got another giant in the field, Doug Engelbart, who is busy answering the really big question, why? Why should we even do any of this? And his legendary system, the NLS, showed the world that the whole point of interactive computing wasn't just to, calculate things faster. The real goal was to achieve this human-computer symbiosis, to literally augment human intellect.
So, let's recap. The software ideas are there. The big philosophical goals are there. But there's a problem, a big one. The hardware is still the size of a room. For this incredible dream to ever reach you and me, everyday people, one more thing had to be true. A fundamental physical reality had to change.
And this was it. You've probably heard of it, Moore's Law. Gordon Moore, one of the founders of Intel, he made this prediction that the number of components you could cram onto a silicon chip would basically double every couple of years. And what that law meant was that those massive, crazy expensive computers of the 60s were inevitably going to get exponentially smaller, cheaper, and way, way more powerful. The room-sized computer would one day fit on a desk, and eventually, right in your lap. So, you've got all these incredible ideas swirling around, right? You've got Sketchpad's objects, Simula's structure, Engelbart's grand purpose, and now you've got Moore's Law as the rocket fuel. So what happens next? Well, Alan Kay and his team set out to actually build the very first version of this new kind of computer. They called it the Flex Machine, and it was designed from the ground up to be a personal computer. It was built around those powerful object-oriented ideas from Simula, but they simplified it all so it could run on a much smaller, more personal device.
And this is the really crucial point here.
The flex machine was basically a declaration of war on the old way of thinking about computers. Mainframes? Those were for the experts in white lab coats. This was for people. Mainframes were these super complex tools. This was imagined as a dynamic learning medium. It was a total, complete philosophical break from the past.
But, you know, the flex machine, as important as it wasn't the whole picture yet. Think of it like a powerful engine. But that final, almost romantic vision of the Dynabook, well, it needed a few more critical pieces to really snap into focus.
Okay, so first, Kay sees this thing called the Grail system, and it had this beautiful, what they called modless direct manipulation interface. Basically, you just pointed at stuff and acted on it. Super intuitive. Then he sees the first flat panel display. It was just this tiny 1-inch square of glass and neon gas, but boom, suddenly the physical form of the Dynabook wasn't just science fiction anymore. You could actually see how it could be built.
And then comes the final piece of the puzzle, maybe the most important one, the soul of the machine. Kay pays a visit to Seymour Papert and sees the Logo project. He's watching little kids, programming computers. And in that moment, he realizes the true destiny of personal computing wasn't just to be a tool for adults. It had to be this profound medium that extended all the way into the world of childhood.
And right there, that's where the final fusion happens. All the pieces just click into place. You've got the object-oriented engine from the Flex machine, the super intuitive interface from Grail, the deep educational purpose from Logo, all of it powered by Moore's Law and wrapped up in the promise of a flat screen. The Dynabook vision was finally complete.
So, you've got this incredibly clear, powerful vision. Now it just needs a place to actually become real. And boy, did it find the perfect home. It was at this legendary new research center that Xerox was starting up in Palo Alto, the one and only Xerox PARC. So at PARC, that whole philosophy that started way back with Sketchpad and Simula, it got refined into this core principle. A designer named Bob Barton put it perfectly. The idea was to build a system recursively. What does that mean? It means every single little component has the same power and the same structure as the entire system. The parts are like the whole. And this amazing philosophy, it gave birth to something called Smalltalk. This was it, the first complete realization of the Dynabook vision, but in software. And its architecture was so simple, it was brilliant. Just imagine a universe of tiny, independent computers, which they called objects, and the only thing they do is communicate by sending messages back and forth.
The rules were so simple, so elegant. Check it out. 1. Everything is an object. A number, an object. A window, an object. The compiler itself, yep, an object. 2. Objects only talk to each other by sending messages. They don't go messing with each other's internal guts. They're polite. They send a message. And 3. Every object is an instance of a class, which is basically its master drawing, just like in Sketchpad. I mean, this is the fundamental DNA of so much of the software we still use today.
Here's the crazy part. Xerox never actually built and sold the Dynabook. But you know what? It didn't matter. Not one bit. Because the real product wasn't the physical device. It was the future it represented. All those incredible ideas born from that vision, Smalltalk, the graphical user interface, overlapping windows, the mouse, they all escaped from PARC and went on to define the next 50 years of personal computing.
So the story of the Dynabook is just this powerful reminder, isn't it, that the biggest, most profound shifts in technology, they don't start with an invention. They start with a new point of view, with a qualitative shift in belief structures. It proves that progress isn't something that just happens to us. It has to be imagined first, which kind of leaves us with a huge question, doesn't it? What new future should we be inventing right now?